architecting sustainable workflows. As you know, the benefit and value of automation in IT is to help organizations streamline provisioning processes, improve accuracy of deployments, and transform into a self-service oriented model. Unfortunately, this conversation typically gets hung up on the underlying physical and logical resource requirements, and as a result, doesn't provide the return on investment needed to make the transformational leap to self-service. There is no doubt that the required standardization of operating procedures, consolidation of resources, and costs affiliated with the hardware and software layers of automation can be cost prohibitive if not done right. As we proceed, let's take a moment to identify a few key fundamentals in approaching a self-service IT model. These fundamentals are standardize and consolidate resources to help ease the transition into workflows, map out the current application to infrastructure lifecycle for service provisioning, leverage API calls versus custom coding, which helps with sustainability and simplicity. Smaller workflows nested together often provide more value than cumulative workflows. And one-off workflows and orchestration calls are typically costly. In order for successful adoption, automation needs to be tied to a business outcome for successful deployments and go-forward deliverables. In order to achieve this level of visibility and sponsorship, all the aspects of service lifecycles need to be accounted for. These aspects take into account enhanced visibility with automated capacity checks and reporting. Change management and approval mechanisms help with the compliance components, as well as cost transparency and forecasting with chargeback and showback. Data protection, backup monitoring and alerting, inventory controls, CMDB, and enterprise service buses for asset control, and most importantly is risk analysis with qualification. As this demonstrates, the conversation often needs to go outside of IT to compliance, quality risk, and the business unit to our stakeholders. However, this conversation does intersect with engineering, of course. In fact, the shift to a typical P3, P4 engineering, as well as enterprise architecture, is such now that one can consider it a hybrid role that directly interfaces with the application and stakeholders as much as traditional IT. In a siloed operations model, a typical dashboard includes the canned workflow elements described above, things such as automated server deployments and template deployments. Though these are a gateway to automation, there are typically several elements needed to be done to massage and complete them. This is a blended model that typically only focuses on infrastructure provisioning, as seen here on the self-service portal, showing that there is a need to have an in-depth understanding and an application-specific requirement and nuance, as well as the underlying hardware and software that we are abstracting from the control of the application owners, should help pave the path to transformation. To highlight where the discussion and value comes, let's take a look at a traditional application provisioning workflow. What I want to highlight here are the numerous amounts of touch points needed to push through the deployment. Note that each touch point is a potential bottleneck and a point of potential error. Fundamentally, the more touch points, the more time between deliverables, and the more opportunity for error. Take a look at what this looks like when overlaid with the elements described above. We have initial approvals. We have capacity checks. We have inventory controls. We then have project management and financial approvals, followed by yet further approvals from typically stakeholders and second-level engagements. Then we have change controls, which also need to be approved and sometimes can only be once a week. After that, we need to tie this back to a showback or chargeback model or reference a project or a budgeted approach. From there, we do things such as back up, add to monitoring, get the right SLAs wrapped around the resources. Then we submit a final go live change control after the application has been developed and we are ready to put this into production. At that point, there'll be a final approval. It'll be qualified. It'll be added to the inventory, and it'll be deployed. Now, Imagine if we can take the input parameters such as business units, project DR numbers, change management requirements, SLAs, and infrastructure such as IP addresses, host names, DNS, etc., and pass those through all the elements of the orchestration octopus so that they are not eligible for change or errors due to manual handoff or human error. We can also audit this and ensure continuity that, in fact, the input parameters are the same as the outputs. Now, let's take a look at how we can leverage certain components of orchestration to build out and nest workflows in a manner that can result in a larger cumulative workflow output, as well as a strategic and focused workflow for other service catalog offerings. In this example, we are building out a virtual machine. We are customizing the applications and OS. We are adding it to the necessary SLAs and support gives for monitoring, alerting, and backup. And more importantly, we are cleaning up the resources in terms of template images and stubs left behind from the provisioning elements. The value here is that we have an end-to-end workflow that is constructed of 5 sub-workflows. Each sub-workflow can then conceivably be its own catalog item. Take a look at the same portal with these new service offerings. The added monitoring, alerting, and backups workflows can be called independently of any build workflow, such that if a standard change window is submitted for a management task, it will be automatically removed from monitoring and alerting for the duration of the change window. This will eliminate any false positive or subsequent fire drills for a planned outage. That is a layer of logic that not only helps tie together the elements of change management, monitoring and alerting, and inventory, but it also ensures that outages are accurate and reduces the amount of time and effort spent by support organizations chasing down issues of miscommunication and delayed outages. There is also on-demand reporting. There is decommissioning of resources and SLA modifications, as well as change management. As we know, there is tremendous value to making this shift as an organization. I have included a brief cost comparison for both traditional and automated IT models to help highlight the financial value behind this approach. There are several soft values that come from this approach as well, such as improved accuracy of deployments due to consolidated and standardized infrastructures and operating procedures, which leads to fewer outages and quicker times to resolution for those outages. So when done right, it will lead to a leaner and healthier IT service, which of course translates to happier end users and added business value versus a traditional cost center. Take a look at traditional provisioning costs versus automated. This is based on a $70 per hour cost and a total hours of 24.5 in traditional model and a 5-hour automation model. This is a savings of upwards of $409,500 a year based on 300 builds, which is an industry average. Thank you.